To enter data, like for a scatter plot, into the calculator, you push the Stat button, hit Enter or number 1 to do Edit, and then you have your lists. We've already entered our X values into L1 and our Y values into L2. Now we need to actually get the line of best fit. And in your notes, here's the directions for finding the line of best fit. Stat, calc, number 4, linreg, ax plus b. So in the calculator, Stat button, how do you suppose we get over to where it says calc? Right arrow. That Stat button has 3 menus within it. There's the Edit menu, the Calc menu, and the Tests menu. So right arrow over to Calc. Number 4 is linreg. That stands for linear regression. Linear means the equation of a line to fit our data. And notice it says ax plus b. Does that kind of look like mx plus b? That's the kind of line we want to have. So push number 4, or you can arrow down to number 4. And this is just setting it up. So they're saying our x's are coming from list 1. That's correct. Our y's are coming from list 2. That's correct. Arrow down until calculate is flashing and hit Enter. The calculator will crunch through that data and tell you the A value and the B value for the line of best fit. So the format of the equation is shown at the top of the screen. And you just need to put those together into your equation. So for our data right here, our equation is y equals negative 1.11x plus 2.27. Because this is a statistical line of best fit, it is likely going to be crazy decimals. You can round as you see fit for your equation. Okay, now I'm not going to show you every single step for this, but I do want you to see this at least once. You are not going to have to do this for your assignment, but there is a way to make this calculator show you the scatter plot. So all I'm doing here is turning on the scatter plot. There's the scatter plot of the data that we just entered. And now here's the really cool thing. If I enter that equation, y equals negative 1.11x plus 2.27, you can see the scatter plot with the line of best fit drawn through the data. Now, you will not have to actually do this on your calculator. That's why I didn't go through the step-by-step process. If you want to know how to do this on your calculator, specifically for those of you who have your own graphing calculator and you may want to know how to do this in your graphing calculator, I will gladly sit down with you one-on-one and show you how to get a scatter plot on your graph, how to get the equation on there. I'll lead you through it. It's easier one-on-one than it is with a whole class. I just wanted to show you, here's the scatter plot. Here's the line of best fit. Isn't it beautiful? Aw, pretty. Aw. All right. Moving on, we need to enter this new set of data. If you go back to the top of this page, clearing out old lists, on your calculator you can push second plus, and then number 4, clear all lists. That will clear the old data out and get your calculator ready for new data. To enter new data, Stat button, Edit. You need to enter your X values into L1 and your Y values into L2. I'm entering the same data again. What am I doing? I don't even know. Now you might be thinking, this takes forever to enter this data in, but take a look at this data. Would you really want to try to graph this by hand? What kind of scale would you use for your y values? Having to go from 180 to 510? That's like craziness. So yes, it does take a little while to enter all of this data, but I promise it's faster than graphing it yourself, drawing in a line that fits the data, finding the equation of that line, and all of that. When you get to the end of your lists, it is a good idea to make sure that both of your lists are the same length. If your lists don't line up, if they aren't the same length, that means that you missed something. You made some sort of a mistake. So check to make sure they're the same length. Okay, we have our data in. How do we get the line of best fit? Stat, calc, for, down, 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 enter. Our equation is y equals 37.45 x plus 172. Okay, now if all I was asking you to do is enter data into the calculator, punch, 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 write down an equation, I'm really just asking you to be a robot. So I'm not just going to ask you for the equation. We now need to take this equation. We're going to save time by not graphing it, not getting our own line. We're going to make the calculator do all of that dirty work for us. Now we need to interpret this equation. So this particular data represents the speed of an airplane during the first 10 minutes of flight with x in minutes and y in miles per hour. One question that's going to be asked on your assignment, they're going to ask you to interpret the slope. So you may need to remember that slope is the change in the y values divided by the change in the x values. If you are finding slope on your own, you'd be looking at subtracting y values on top, subtracting x values on the bottom. Our y values are miles per hour. Our x values are minutes. So first thing that I want you to think about, is our slope increasing or decreasing? Increasing because it's positive. So this slope shows that the airplane is increasing 37.45 miles per hour each minute after takeoff. Because the slope is y's divided by x's, that's miles per hour over minutes. So 37.45, that's how many miles per hour we are increasing every minute. The next thing that they're going to ask you is, using your model, remember model is another word for equation. So using your model, assuming this pattern continues, estimate the speed of the plane at 12 minutes after takeoff. X represents minutes, so we're using x equals 12. Plug that 12 into your equation. They're simply asking you, use this equation for another x value. So y is going to equal 37.45 times 12 plus 172. Somebody punch that in. 621.4. So 12 minutes after takeoff, assuming that this pattern continues, the airplane would be moving at 621 miles per hour.